Okay, so now we'll move on to the next chapter, chapter 4, probability. Okay, so when it comes to the probability chapter, first you need to understand the vocabulary we use in probability. So the first thing is, if you want to predict the change of something happening, we use probability. Obviously, if you want to predict the chance of something happening, right? So there might be an event, and you need to, give the chance you want to predict, like, what's the percentage that this particular event will happen. So that's the probability. Okay, so these are the vocabulary we use. An experiment is a repeatable process that gives rise to a number of outcomes. Okay, so the first thing we need to use, first word you need to know here is that what is an experiment. So an experiment is something you can keep repeating, maybe like tossing a coin, tossing a dice. Okay, and then so when you repeat the experiment, it could give you different outcomes, right? So basically, if you're tossing a coin, you can get a head. Another time you might get a tail. Like, or if you're tossing a dice, you can get outcomes 1, 2, 3, 4, 5, 6, isn't it? Okay, so those are experiments. An event is a collection of one or more outcomes. Okay, so what's an event? An event is a collection of one or more outcomes. I think these will be more clear when we do sums. But right now, just have the idea. Okay, a sample space is a set of all possible outcomes. So for basically, if you're tossing a coin, what's the sample space? All the possible outcomes are for a coin. It's going to be either head or tail, right? Or if you're working with a six-sided dice, what are all the possible outcomes? You get 1, 2, 3, 4, 5, 6. So those are the 6 possible outcomes. Okay, and then they say where outcomes are equally likely, the probability of an event is the number of outcomes in the event divided by the total number of possible outcomes. Okay, what do they mean by that? Like, for example, where events are equally likely. An example where events are equally likely, you could take a coin. Now, when you take a coin, it's equally likely that you get a head or you get a tail, isn't it? Because both sides have an equal chance. So but there are only two sides, right? You get either head or you get either tail. And so there are only two outcomes. So what's the probability that you'll get a head? What's the probability that you'll get a head? So you can see there are only two outcomes. So because of that, you will write 2 at the bottom, and head is just one of those outcomes. So half, 1 over 2. Okay, so that's one example. Or let's say the example of a dice. So in a dice, your outcomes are 1, 2, 3, 4, 5, and 6. These are the outcomes. So what's the probability that you get, let's say, 3? So what's the probability that you get now, in a dice, in a six-sided fair dice? Obviously, I'm considering a six-sided fair dice. Okay. So in a fair dice, all the all the sides have an equal chance. That's why they say equally likely. Equally likely means every single side has an equal chance of being selected. Okay. So they are saying to get the probability, what do you do? So you have altogether 6 outcomes here. So you'll write at the bottom 6, and 3 is just one of the sides. So 1 out of 6. And that's why they say where outcomes are equally likely, the probability of an event is the number of outcomes in the event. So number of outcomes, in this case, my event is getting a 3. So 3, there's only one event of getting 3 over 6. Okay. So, and then they say all events have probability between 0 and 1. Okay. So probability values are always going to be between 0 and 1. Okay, so that's why we always get fractions. Normally, probabilities are always written decimals or fractions. Okay, so and always these values are going to be between 0 and 1. So if a certain event has a probability 0, it means that event is never going to happen. So for example, I'll ask you what's the probability of getting 7 here? Can I get a 7 here? Like, I'm going to toss the dice and I'm going to get a 7. Is there any chance that I will ever get a 7? No. So it's zero probability, because that's something that will never happen. Okay. 0 is impossible. And 1 means it's certain. Certain means this is definitely going to happen. Now, of course, I can't say any of the sides here with certainty. But like, I mean, normally a probability of 1 means this will definitely happen. That particular event is surely happening. Okay, so probabilities are usually written as fractions or decimals. Okay, so these are the main vocabulary. The main vocabulary you need to understand when we are working with probability. Okay, so let's move on to exercise 4A. They say two coins are tossed. Find the probability of both coins showing the same outcome. Okay, so how do we get this? Okay, we are tossing two coins, not just one, right? So if you're tossing two coins, it's best you draw a proper sample space denoting all the possible outcomes from both the coins. So the best way to show outcomes of two different coins is to consider a two-way table. So a two-way table is something like that looks like this. You could of course draw the axis to any side. So I will say this is the first coin, coin one. This is coin two. So in a coin, what are the possible outcomes? In coins, the outcomes are head and tail, right? You don't have anything else. Head and tail. So over here also we have head and tail, right? Okay. And you can see what are the outcomes. The first outcome over here, so these are the places. So you can see there are 4 points of intersection. So first one, the intersection is head-head, which means what? From the first coin you get a head, and from the second coin also you get a head. Can you see? The second outcome is from the first coin you get a head, from the second coin you get a tail. And then over here, the other one, from the first coin you get a tail, from the second coin you get a head. And in the next one, from coin 1 you get a tail, from coin 2 you get a tail. Can you see? So these are the 4 different types of outcomes we can get. Is there any other possible outcome that I could possibly get when I toss two coins? Like I have written all the possible outcomes, like we toss the two coins and whatever that comes on top, like all the possibilities that you could get. So I have written these are the only 4 possibilities, right? We don't have any other possibility here. Right. So they are saying, so you can see we have 4 different options. There are 4 different options. So two coins are tossed. Find the probability of both coins showing the same outcome. So both coins showing the same outcome means either both coins are going to be heads or both coins are going to be tails. Isn't it? Same outcome means both are heads or both are tails. So how many such outcomes are there? You can see 2 such outcomes are there, right? Out of total what? Out of what's the total number of outcomes? You can see in our sample space, we have 4 different outcomes. So out of 4, the total getting the same outcome, we have 2 chances. So 2 over 4. Can you see 2 over 4 is what reduces to 1 over 2, half. So this is the final answer. Okay, so let's move on to question number 2. They say 2 6-sided dice are rolled and their product X is recorded. Can you see? So we roll 2 dice and whatever the answer you get from the 2 dice, we multiply it. That's why they mean by the product. So you get the product and then you record it. Okay. So draw a sample space diagram showing all the possible outcomes of this experiment. Okay. So let's draw the sample space. First thing is you have 2 6-sided dice. So the dice 1. This is this. We actually using singular die. Okay. So the sides are numbered 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And the other one also 1, 2, 3, 4, 5, and 6. Okay, so by the way, they are saying that they are considering the product here, isn't it? They say they are considering the product here. Okay, so they are considering the product here. Let me. Okay. Okay. So over here in this case, you can see dice 1 gives 1, dice 1 has given outcome 1, dice 2 has given outcome 1. So basically you're supposed to get the product. So product means 1 times 1, the answer, the outcome that we require, the x outcome is 1. Okay, so over here in this case, dice 1 is giving 1, dice 2 is giving 2. So 1 times 2, the answer, I mean the x value that we record is 2. Okay, the next one here, 1 times 3, that's a 3, 1 times 4 is 4, 1 times 5 is 5, 1 times 6 is 6. So you see what I'm doing here. Okay, I'm directly writing the answer that we consider for x. Basically, x is the product. So over here, dice 1 is 2, dice 2 is 1. So 2 times 1 is 2, 2 times 2, this is a 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5, 10, 2 times 6, 12. So here 3 times 1, 3, 3 times 2 is 6, 3 times 3, 9, 3 times 4 is 12, 3 times 5, 15, 3 times 6, 18, right? 4, 8, 12, 16, 20, 24, 5 times 1, 5, 10, 15, 5 times 4, 20, 5 times 5, 25, 5 times 6, 30. And then the last one, 6 times 1, that's a 6, 6 times 2, 12, 6 times 3, 18, 6 times 4 is 24, 6 times 5 is 30, and 6 times 6 is 36. So these are, as you can see, these are all the possible outcomes that you could possibly get for x. X is the product. So I have written every single outcome that you could possibly get for x by rolling 2 dice. Okay. So this is all the possible outcomes that you could possibly get for x. I mean, in this particular case, okay. Okay. So in this particular case, when x is 24, you can see there are two cases, right? So there are two outcomes where x is 24. So we write 2 out of what's the total number of outcomes? 1, 2, 3, 4, 5, 6. 6 times 6. There are 36 outcomes, right? So 2 over 36. So 2 over 36 is 1 over 18. Right, agreed. 2 over 36 is 1 over 18. That's the answer for Roman number 1. Roman number 2, you have to get the probability x is less than 5. So you have to get select all the outcomes where x is less than 5. So what are they? I can take 1, 2, 3 is correct, 4 is correct, less than 5. So you can't take 5. So we can't definitely go with 5. So 6, they don't work. Only the ones lower than 5. 6 doesn't work. Over here, we can take 3. Over here, we can take 4, right? I think that's it. These are the only possibilities I have where x is lower than 5, right? 1, 2, 3, 4, 5, 6, 7, 8. So 8 chances out of 36. Do you agree? 8 out of 36. So 4 times 2 is 8. 4 times 9 is 36. So the final answer is 2 over 9. Agreed? Roman number 3, they say probability x is even. So guys, you have to select all the events where x is even. So where do we find the even one? 2 is even. We'll go row by, let me go in order. Let's go, column by column. So 2, 4, 6, and again 2, 4, 6, 8, 10, 12. Again over here 6, 12, 18. I think you guys can see. You just need to count all the ones where x is even. In this case, I think everyone counts, right? All of these are even. In here, 10, 20, 30 is even, and here again, everyone is even. So you have to count all of these and see how many are there. So I think most of the people are there here, right? 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So out of 36, we have 27. 27 where x is even. So 27 over 36, we could simplify by 9, right? 9 times 3 is 27. 9 times 4 is 36. So it's 3 over 4. Okay. So this is the probability that x is even. Okay. So next I'll move on to question number 3. The masses of 140 adult bull mastiff dogs are recorded in a table. One dog is chosen at random. Find the probability that the dog has a mass of 54 kilograms or more. Okay, so the masses are given to you here. You can see masses are between 45 to 48. You have 17 dogs. Between 48 to 51, there are 25 dogs and so on. Okay, so they want the probability that the dog has a mass of 54 kilos or higher or more. So I think you can see 54 is, this is where we end 54. I mean, basically 54 and higher is in these three categories, right? The mass between 54 to 57, 57 to 60, and 60 to 63. This is where you have the mass categories that are 54 kilograms or higher. So how many dogs are there in this category? All you need to do is add the value 33 plus 21 plus 2. So add it. So probability mass higher than, greater than or equal 54. Mass is simple M, right? Probability mass is greater than or equal 54. So what's the total? 33 plus 21 plus 2. That's 56, right? 56 out of, what's the total here? Get the total frequency. I think total frequency they have, yeah, it's 140. The masses of 140 adult bull mastiff dogs. So it's total should be 140, right? So 56 out of 140. And then make sure if it simplifies to simplify. So does it simplify more? Yeah, I think we can divide it further, right? It divides further and gives the answer as 2 over 5. Agreed? Yes. Okay, so then let's move on to part B. Find the probability that the dog has a mass between 48 and 57. So you have to find the probability that it has a mass between 48 and 57. Okay, so between 48 to 57, I think you can see the mass is between 48 to 57. Can you see? Between 48 to 57. So this group. Guys, can you see? So here you have the masses that are greater than or equal to 58, less than 57. So between 48 and 57 basically. So probability mass between 40. So we can write like this. In this case, M is greater than or equal 48. And this is less than 57. Okay, because of the table. Because in the table here, this is greater than or equal 40. Here it's less than 57. So in that category, how many dogs are there? So add the value. You have to add 25 plus 42 plus 33. 25 plus 42 plus, plus 33. So when you add it, the answer is 100, right? Yeah. So 100 out of, so probability you write from the total is 140. So simplify. So 5 over 7. Right, so the answer 100 over 140 simplifies to give the, it simplifies to be 5 over 7. Okay. Okay, so let's move on to part C. Okay, so the next question, they say the probability that a bull mastiff chosen at random has a mass under 53. Okay, mass under 53 is 0.54. Okay, so they have given that, right? The probability that a bull mastiff chosen at random has a mass 53 kilogram is has a mass under 53 is 0.54. Okay, is it more or less likely that a bull mastiff chosen at random has a mass under 53 kilograms? State one assumption that you have made in making a decision. Okay, what's going on here now? They are saying they are giving you the probability that the mass, okay, probability that the mass is under 53 is 0.54. But they are asking you, is it more or less likely? I mean, they are asking whether the probability that the mass under 53, is it lower than or higher than this value? Is it more or less likely that a bull mastiff chosen at random has a mass under 53? So basically what you need to do is, you need to calculate this probability by using this table. You need to calculate the probability that mass is less than 53 by using this table, and then you need to compare it with this value and say whether it is more or less likely. So if the answer you get is bigger than 0.54, it's more likely. If it is smaller than 0.54, it's less likely. So now you have the task of what? You need to calculate the probability that the mass is less than 53 by using this table. But I think you can see when we try to do this, in this case, we do run into a problem. So what is it? Because you can see in the earlier questions, we were dealing with the exact boundaries they had given, but now 53 is not a exact boundary. Can you see 53 is somewhere in between 51 to 54? So in this case, we have to go with what? We will have to go with linear interpolation, because this is continuous data, mass continuous. So you need to find, basically what I need to do is, I need to find, I mean, we know at this point, let me show. So we know at this point between 51 to 54, right? So mass is between 51 to 54. Okay, in between, in this category from 51 to 54, there are 42 dogs. The difference between these two is 42. Okay, so that's 53 here. What I really want is the number of dogs in this category. N, let me put it as N. I want to know out of the 42, because I know between 51 to 54, I know between 51 to 54, there are 42 dogs. So out of that 42, I want to know how many of that, out of that 42, how many are going to be between 51 to 53. Because end of the day, I want to know the total number of dogs that are, I want to know the total number of dogs that are actually less than 53 kilograms. Okay, are you guys with me? So you can take the cumulative frequencies here as well, but I have taken the differences. So in that case, you really don't need the cumulative frequency. You can immediately do this because we know the differences. Otherwise, you can write the cumulative frequencies here. Okay, so let's go for the interpolation. So first one will be 53 minus 51. So we subtract the weight over 54 minus 51. Okay, so I'm taking this in the with the categories I know. 53 minus 51 is this gap. Over 54 minus 51 is the large gap. So on the other side, with the cumulative frequency also, I should take the same gaps. So over here, the same gap for the cumulative frequency for 53 and 51, the frequency difference is n, because I have directly written the frequency difference. That is n over the large gap, 54, the cumulative frequency of 54 and the cumulative frequency of 51. If you subtract, you get the frequency in between, that's 42. So I'm directly using those values. Okay. So if you are not comfortable, you could calculate a cumulative frequency table here and write the cumulative frequencies and put the values. So no problem. Okay, so I'm going to get the n value here. I'm trying to find how many dogs are there between 51 to 53. Okay, so let's do the calculation. 53 minus 51, that's 2 over 3 into 42 equals n. Agreed? So how much is n? 2 over 3 into 42. It's, so get the answer here. 28, right? Yeah. So n is 28, which means out of the 42 dogs, 28 of them are between 51 to 53. Okay, so remember, as you remember in interpolation, we always assume that these now there are 42 values here. So we assume that these 42 values are equally distributed in the interval, right? We always assume in interpolation that it's equally distributed. Okay, so out of the 42 between 51 to 53, you find 28 of the dogs between 51 to 53. Okay, so my question is to find the probability that the mass is under 53. So probability that the mass is under 53. So how many dogs are under 53 kilograms? How many dogs are under 53 kilograms? So you can see 45 to 48 is under 53. So that these 17 dogs come. And 48 to 51, yes, this is also under 53. So these 25 dogs are also under 53 kilograms. Can you see? But in the next one, 51 to 54, I can't take this full one because I need the masses under 53 kilos. So you can see, I need the masses of, I need the dogs from 51 to 53. Okay, not 51 to 54. So 51 to 54, there are 42 dogs, but 51 to 53, there are n number of dogs, which we found n is 28. So you will write 28 here. Can you see? This is really important that you understand how I got this here. So 17 dogs with 45 to 48, which is under 53. First 25 dogs in the 48 to 51 category, which is under 53, which is under, which is under 53. And then next one, 51 to 53. 51 to 53, the number of dogs is n, which is 28. So this out of 140. How much is it? 70 out of 140, yeah. 70 out of 140, which is half, 0.5. Can you see? So the probability from our table is 0.5. So is the probability greater or smaller? I think you can see this is smaller, right? Can you see? This is actually small in comparison to this. Okay, so we'll give the conclusion. So end of the day, you can see since it is lower, we can say it is less likely. Okay, because 0.5 is less than 0.54. Okay, it is less likely because 0.5 is smaller than 0.54. And also, what's the main assumption that we did here? So remember that one of the main assumptions that we do when we are using interpolation is always what? We assume, we always assume that the frequency is the frequency is evenly distributed. Okay, we always assume in interpolation that the frequency is evenly distributed. So right, assume, they are asking the assumption, assume frequency is evenly distributed. Is evenly distributed throughout the class. So that is really important. Okay.